Hello and welcome back to RISC OS Direct, the information and tutorial series all about the RISC OS operating system for the Raspberry Pi. Previously we showed you the gaming and retro computing emulation options available as standard under RISC OS Direct. This included new game releases as well as support for older entertainment titles. Today we're going to look in more detail at the multiple and flexible networking options, web browsers and client software available and pre-installed as standard. Before we continue any further, a quick update on where to find and download the latest versions of RISC OS Direct. Previously we directed you to riscosdev.com/direct, and although this will still work, all future builds and downloads will be found on the main riscosdev.com website by clicking the Projects tab. From here, you'll find the official download and, if required, our Google Drive mirror. As always, if you're watching this series for the very first time and are brand new to RISC OS Direct, we strongly advise watching back episode 1 of this series, Getting Started, and follow our video guide. For the following demonstrations, your Raspberry Pi is going to need an internet connection. RISC OS cannot at present support a Wi-Fi connection, even if the hardware is present on your Raspberry Pi board, meaning you will require an Ethernet type cable connection, which using a suitable patch lead can be plugged into your Pi's Ethernet network jack, with the other end into a cabled network or, if at home, one of the 3 sockets on the rear of your broadband router. On the first boot up, RISC OS Direct requires a few moments to look for an internet or network connection. This process is needed if you do intend to use RISC OS online. Once a connection has been found, your Pi will forward to the main desktop. A pop-up will appear on the lower right-hand side of the screen, notifying you that a connection has been found. If no connection is found, or if the connection is lost, this pop-up will also notify you of that as well. As a result of being online, you will notice the time and date displayed is now correct at time of recording. As the Raspberry Pi does not by default come with a real-time clock, most Pi sessions lose time when running offline. RISC OS Direct comes with 2 pre-installed web browsers. These are NetSurf and Otter Browser, both of which can be found on the desktop pinboard. NetSurf is a lightweight browser that supports most basic web protocols. It runs fast and efficiently, even on the oldest or slowest Raspberry Pi boards. However, it does not support newer web features, such as HTML5 or the media plugins, meaning sites like Facebook and other social media platforms won't work correctly or if at all. The second featured browser is Otter Browser, which is a little more heavy duty and as a result requires a Raspberry Pi 2 as a minimum to run. However, we strongly recommend a Raspberry Pi 3 or later for best performance. On double left clicking the Pling app icon to open, some users have reported Otter Browser appears to lock up or crash the system. However, we can assure you this isn't the case, and after a few moments Otter Browser will launch either a new web browser window, or if you are returning to the browser from a previous session, you will be greeted with a welcome dialog giving you options to continue a previous browsing session or start a new one. Once started, Otter Browser works in very much the same way as any other modern web browser, with the added advantage that it does support some newer HTML5 and interactive content features, meaning services like Facebook will work. It is the intention of RISC OS developments to replace Otter Browser with a new build web browser shortly, which will conform to modern WebKit and HTML5 standards, giving a much better web experience on the RISC OS platform. As with any modern operating system of note, RISC OS Direct comes equipped with its own online app store. Known as the Pling Store, the app simply called Store can be found in the Apps folder. As with all standard RISC OS apps, left double clicking that Store icon will open the app. The Pling store will first look for an internet network connection, so your Raspberry Pi will need to be connected and online. Pling store will then check for any updates before displaying its main menu window. If you wish to purchase any software, you will first need an account. This can be set up by left-clicking the Login button, making sure the first option, Create New Account, is selected, followed by filling in the required personal information. However, you don't need to register if you only intend to download and use the free software and apps made available in the Pling store. The full catalogue can be viewed at once by left-clicking the Catalogue button, or individual software genres can be viewed by left-clicking the Categories option. Let's choose a new piece of software from the Categories option to download. From the sub-window list, we'll left-click an option, in this case the freeware public domain categories. This will place a small green tick next to it. With our chosen category selected, we can left-click the Open Apps List button on the top bar. This will produce a further window showing all the applications in the Pling store system that are free or public domain. From the list, let's choose an app to download. We can use the up and down scroll arrows, or left-click and drag the scroll box to scroll the list up and down if required. For this demonstration, let's choose the Weather UK app from RComp by double left-clicking it. This will produce a fourth window showing the app information. To download this app, we simply left-click the Get App button. If you're not logged in or do not have a Pling store account, you'll get this warning dialog. You can optionally left-click the Don't Show This Warning Again tick box if you wish, but for this demonstration we'll left-click the Continue Download button. Once the download is complete, a new Filer window will appear with the newly downloaded app inside. We can now move this app to where we want it on our system. In this case, we'll place it in the Apps folder found in the main SD card directory. To do this, we can simply left-click and drag the app icon over to its new location. Our new Weather UK app is now installed, and so can be opened like any other Pling app on RISC OS, with a double left click, with the app loading into standby mode in the lower right of the icon bar. Left-clicking this app once will launch the app, which produces a new window showing the latest weather information for the UK. A modern way of working with Raspberry Pi is to run what's called Headless. This is where a Raspberry Pi is set up to run without a keyboard or monitor attached and is accessed and controlled remotely by another computer or mobile device. The system that allows this type of operation is called VNC. Setting up the VNC server in RISC OS Direct could not be easier. We first need to set up the VNC server module that comes pre-installed with your RISC OS Direct installation. This can be found under the main SD card directory by double left clicking the network folder. Inside, double left click the servers folder and then the VNC server folder, where you will be presented with 4 icons: a README text file, 2 obey files labelled as start and stop, and finally the VNC server module itself. To start the VNC server, we can simply left double click the start obey file. It should be noted that nothing will appear to happen. This is normal. To stop the VNC session at any time, simply left double click the stop obey file. This will cut the server, so any users logged in using the RISC OS desktop will be cut off and disconnected. To set up or change the settings, hold down the left shift key and double click the start obey file. This will produce a text window with the flags and parameters including setup for network port number and password. The defaults are port 5900 and the login password is Bob or B-O-B. We strongly recommend changing the password and, if necessary, the port number for security reasons. However, for the purposes of this demonstration, we will leave both in their respective default states. One setting we do recommend changing is that of the mouse buttons. The last option, titled Swap Adjust Menu, If set, will swap the middle and left mouse buttons for any computer accessing RISC OS via the VNC server. This is useful if accessing the desktop from a computer or device that only has left and right mouse buttons, such as a laptop trackpad. To set this parameter, replace the 0 with a 1, and then left-click the floppy disk save icon on the window toolbar, left-clicking Save from the dialog box. Swapping the mouse buttons this way will only affect remote computers and not mice or pointer devices plugged directly into your Raspberry Pi, which will remain using RISC OS's default button configuration. At this point we're almost ready to start, but there is one more setup option we need to do. If we plan to run our RISC OS desktop headless, that's without a keyboard, mouse or monitor plugged in, we need the VNC obey start file to start on boot up. To do this, first navigate to the start obey file as previously shown. Then, from the pinboard, left double click the configure icon option, and from the window left click once the boot icon. From the boot sequence window, left click once on the run icon option. This will produce a list window called Run at Startup. Any item shown in the list will automatically run every time RISC OS is booted or restarted. To add our VNC server start obey file to this list, simply left click and drag the file over to the list box where it will appear once you release the left mouse button. To save this change, click the Set dialog button, and then from the previous window also click Set. All other windows can be closed in the normal way. This boot on startup method can also be used for any apps, obey files, or even basic programs you wish to load or run. With VNC server now fully set up, we can attempt to run our RISC OS Direct powered Raspberry Pi headless for the very first time. But first, we need to obtain our Raspberry Pi's IP address. This is a unique number the Pi uses to identify itself to other computers on a network. To do this, first make sure your Pi is connected to your network. Then press the F12 key on your keyboard once. This will produce a task command prompt at the bottom of the screen, pushing the screen's content upwards. All desktop functions, including the use of the mouse, will be disabled during this process. We can now type ifconfig-a, followed by the return or enter key, and make note of the address it returns. This might be the same or different to the one shown in this demonstration. Now, making sure we've shut down RISC OS and powered off our Pi board, we can remove all cables from the Pi if required. This means we can move the Pi board to a location near our home broadband router or a similar convenient area if required. In this case, we can use a simple Ethernet patch lead to connect our Raspberry Pi to this home broadband router. All we then need to add is the Pi's power supply and turn the Pi board back on. Next, we'll need a third-party VNC client app for any device we intend to use as a VNC client. We recommend using VNC Viewer, which can be found on your device's app storefront. Here on the Mac, open VNC Viewer and click File, New Connection. In the window that appears, put the Pi's IP address into the VNC server text box, followed by an identifying name in the box below. In this case, we'll call the connection RISC OS Direct. Then click the OK dialog button. Now double-click the RISC OS Direct icon. VNC Viewer will attempt to make a connection. If successful, you'll be prompted for a password. The default is Bob, followed by clicking the OK button. Again, if successful, you should see the RISC OS Direct desktop appear in a new window within your Mac, PC or Linux environment. A similar process can be done for mobile devices. Here, RISC OS Direct is being VNC controlled by the touchscreen interface of this iPad, again using the VNC Client app, which is free from the Apple App Store. So we've seen how to use RISC OS remotely on another computer system. But how about the other way around, using another computer system remotely on RISC OS Direct? Well, that's where Avalanche comes in. For this demonstration, we'll use a second Raspberry Pi board running a custom Linux setup to act as our VNC server. As before, this will be added to our home or office network, or if set up with static IP addresses, the two Pi boards can be connected directly to one another. Linux Raspberry Pi setups are outside the remit of this series, but plenty of information about setting up VNC servers for Linux and other computer systems can be found online. Back to RISC OS Direct, left double click the Avalanche icon on the main pin board. This, like many RISC OS apps, will load into a standby mode with its VNC icon appearing on the lower right of the icon bar. Middle clicking this icon once will produce a submenu from which the New Connection option can be left clicked. This will produce a New Connection dialog window where we can enter the network connection. In this case, the host machine's IP address, a colon, followed by the port number, in this case 5901, but some setups might use 5900. We also need to make sure the interactive tick box is ticked, which should be by default, before left clicking Connect. Next we'll be asked for the connection or user password for the machine we're connecting to. This will be your host OS's user password, or the one set up by the VNC software being used to host the computer you're connecting to. After entering the password, left click the OK button. You should now see a new desktop window containing the active desktop from your host machine. As you can see by this example, it's sometimes necessary to expand the window size to see all the available desktop space. Linking other OS desktops to RISC OS via Avalanche allows the use of non-RISC OS applications and environments inside your RISC OS Direct system. This is ideal if you want to use RISC OS Direct as your main computer hub interface for a multi-system network, or use non-native or more common applications not supported by RISC OS at time of recording. FTP, or File Transfer Protocol, is a network-based system for sending files to and from remote servers or computers. Since the birth of the modern internet, FTP client software has been used to upload and maintain websites, especially in the days before major social media networks or content management systems like WordPress. An FTP client can also be useful for moving files between computer systems, especially if they happen not to be running the same OS. For any FTP requirements, RISC OS Direct comes pre-installed with FTPC. FTPC can be found in the network folder on the main SD card directory. As with most other software we've shown you today, FTPC will load into a standby mode when double left clicked. Left clicking once the FTPC icon that's now appeared on the lower right hand side of the icon bar will produce a new connection window, ready for the server information we want to connect to. For this demonstration, our Linux-based Raspberry Pi has been set up with a local host server program called VSFTPD. As with the VNC demonstrations from earlier, all we need is the second Pi's IP address, username and account password. We can, in this case, leave all other settings as is and all other text boxes blank before left clicking once the connect button. You should then see a files window space containing the set FTP directory of the host computer. If we wanted to share a file, like this text document, we can simply left click and drag and drop it into the FTP files window, where a copy will be made and the file transferred to the host computer. If we look at the XFCE Linux desktop of the host computer, we can see the file has indeed arrived and can be opened and, if needs be, edited. As you can see, this FTP process is extremely simple and allows for easy transfer of files and data via a network between RISC OS and other computer systems or servers. A common feature often requested by new users to RISC OS is the ability to use SSH, or Secure Shell. This process, which is very common on Linux or Unix-based computer systems, allows one computer to talk to and log into another, displaying its output via a text terminal on the first computer. For this demonstration, we'll again use our RISC OS Direct for Raspberry Pi to talk via a cabled Ethernet network to a second Raspberry Pi running a stock build of Linux-based Raspberry Pi OS. For an SSH connection to be established, the host computer, in this case the second Raspberry Pi running Linux, needs to have SSH networking enabled. We first need to activate the SSH app, which can be found in the network folder on the main SD card directory. Left double clicking SSH or Open SSH will load in the required network module, although you will not see any changes. As with BNC Server, if you require SSH from boot up, you can add the app to the boot run items list as shown earlier. With SSH running and the Pi running RISC OS Direct connected to a local network, we can open a new task window which acts as RISC OS's main terminal. From the RISC OS desktop pinboard, middle or scroll wheel click the blue cog on the lower right hand side of the icon bar. From the sub-menu, left-click the Task Window option to open a new Task Window terminal session. Unlike the Unix or Linux terminal, RISC OS uses a command syntax based around what are known as star commands. To SSH into our second Pi, we need to call star SSH space, followed by our host machine name, in this case Pi, followed by the @ symbol, followed by the second Pi's IP address. Once the line has been typed, we can press return or the enter key. If the network link is successful, we'll be prompted if we want to accept the connection. If all is well, this should forward us to the Raspberry Linux boot prompt, from which all following commands will be in Unix or Linux syntax, and affect the second Pi machine only and not the first running RISC OS Direct. For example, we can call up the Python interpreter by entering the word Python, followed by the return or enter key. When we are finished with our session, we can simply close the task window and left-click Discard from the following dialog. However, this process will only close the connection and will not shut down the Linux computer we are logged into. Well, that brings us to the end of this edition of RISC OS Direct. If you've been inspired to download or try the OS for yourself, you can download it for free from www.riscosdev.com. And if you're watching this video on the youtube.com/Wi-Fi Sheep channel, then don't forget to like and subscribe. Next time we'll get coding as we look at a number of programming languages and environments available out of the box with RISC OS Direct. We'll be going back to basics with the modern 32-bit version of BBC Basic, as well as its 21st century equivalent in the form of Python 2 and 3. That's coming up next time here on RISC OS Direct.